is the May 2011 paper 2, problem number 2. Problem 2 is a Venn diagram. We're giving some information about what we should put into our Venn diagram. One day, the number of customers at 3 cafes, Alan's Diner, Sarah's Snack Bar, and Pete's Eats, was recorded and are given below. In the mark scheme for this problem, it indicates that for part A, draw a Venn diagram using sets labeled A, S, and P that shows the information. You get full marks if you have a box drawn around your 3 circles. So don't forget that drawing this box is very, very important to the problem. And you want to make sure that you label the entire set, the universe, and then have your 3 sets drawn with intersecting circles. And then we need to appropriately fill in that 17 customers, I'll just underline that, 17 customers ate at Pete's Eat, 27 ate at Sarah's Snack Bar, 15 ate at Alan's Diner. And then 10 were customers of Pete's Eats and Sarah's Snack Bar, but not Alan's Diner, and 8 at Alan's Diner and Pete's Eats, but not Sarah's Snack Bar. So that's the information that you need to be showing in part A of question number 2. And then we're given some additional information. There were 48 customers of Pete's Eats that day. So we know that the total number of customers at Pete's Eats is 48. Calculate the number of people who were customers of all 3 cafes. So there are a couple of things that we need to do. For part B, we know that, let's see, we have 48 total, so this is part B. We have 48 total, and what do we already know? We already know that 8 and 10 and 17, those spots are filled up for us already. So the part that's left that we have, that's going to go right, you guys can't see me waving my finger over this little intersecting circle, is going to be 13. So we know that right there, 13 customers ate at all 3 of the diners. We also are given in part C that there were 50 customers of Sarah's Snack Bars on that same day. So we go to Sarah's Snack Bar, and using the same method. Now again, I keep emphasizing this. On paper 2, you have to show work, even if it seems kind of obvious what you're doing. You're not going to get any points. You're not going to get method points if you just write down the answer and don't show how you got to the answer. So we're going to follow the same method. 50 customers were at Sarah's Snack Bar in total, and we know that we've accounted for 13 and 10 and 27 of those 50 customers, and that means that there were 0 that ate at both Alan's Diner and Sarah's Snack Bar. But what we're asked to find is the total number of, in part C, we need to find the total number of customers that ate at Alan's Snack Bar. So if I look at Alan's Snack Bar, ooh, I didn't mean to do that. Oopsie. Let's see if I can undo that. What happened there? So if I look at the total number of customers that ate at Alan's Snack Bar, I'm going to add up, I want that to be purple. We're going to add up those values. Then we've got 15 plus 8 plus 13, and that means the total that ate at Alan's Snack Bar is equal to 36 customers. That's what we're asked to find in part C. In part D, we're going to find the number of customers of Alan's Diner that were also customers of Pete's Eats. So we'll take, let's see, Alan's Diner that were also customers of Pete's Eats. We'll take, can you see my blue? I'm getting kind of crowded here. We'll take these values. So that means we're going to take 13 and we're going to add 8, so that's 21. We've got 21 customers there. And then, oh, this last part looks kind of scary. Let's see what they want us to do. Find the number. So this little n means the number of elements in this set. So let's see what we're asked to do. We're going to take, now I can't see that. Does that say, it says Sarah's Union Pete's, and then we're going to intersect that with everything that's not in A. So let's see what we've got. I'm going to take my yellow highlighter, and I've got Sarah and Pete. So we're going to take everything here and everything here. And then we're going to overlap with everything that's not in A. So I'm going to change my highlighter color, and we're going to go, where does that intersect with everything that's not in A? And I wish I wouldn't have written over that with like double. So we're just going to kind of go here and here and here, because what I want you to be able to see is that kind of lighter pinky color. Let me outline that in black. Where my intersection is going to be, it's not black, here and here and here. That's all the stuff that's everything that's in S and P intersecting with everything that's not in A. And that what we need to do is add up the number of elements that are in those three sets. So what we have is 17 plus 27 plus, I think that was a 10. I can't see anymore. So I've got 17 plus 27 plus 10, and that gives me a total of 54 elements in those sets. And that looks kind of messy, but I think you get the point.